Alright, today we're going to be looking at solving equations using the auxiliary angle method. So to solve these equations, we just need to apply our method, but then we've got an equal sign at the end. When we're solving these equations, if it's not stated, we're always going to put it and make it easy for ourselves and put it in its natural form. Generally, it is stated, however. So the natural form of root 3 cos x minus sine x, well, the radius is going to be 2, and then it's cos of x plus tan inverse of 1 on root 3. Tan inverse of 1 on root 3, which is 30 degrees. So cos of x plus 30. Now, I just had a little thought. I don't know why I keep calling it radius. That's actually incorrect. The correct term would be its amplitude, because this is actually representing the amplitude of a cos graph, and that's equal to 1. We'll have a go at solving this by dividing both sides by 2. Cos of x plus 30 is equal to 1 over 2. Now, cos inverse of a half is equal to 60 degrees or 300 degrees, because cos is positive in both the first and the fourth quadrants. Now, the way we solve these, please don't do what the textbook does and make this equal to u and then put a u here and then solve it all. Just say, okay, if this was normally a theta, then a theta would go here. But instead of having a theta, we've got an x plus 30. And we're just going to solve both for x plus 30 by minusing 30 from everything. So we're going to get x is equal to 30 or 270. Okay, question number 3. Sine of theta minus cos of theta is equal to 1. The only way we can solve this using the auxiliary angle method is by subtracting the 1 to the other side. So we've got sine of theta minus cos of theta equals minus 1. Now let's put that in its natural form. Its amplitude, r, is going to be the square root of 1 squared plus 1 squared, which is root 2. So we're going to make it a sine. X minus, because we've got a minus here. Now tan inverse of 1 on 1 is pi on 4, so this is pi on 4 here, and that's equal to minus 1. We're going to divide both sides by root 2, so sine of x minus pi on 4 is equal to minus 1 on root 2. And now that means we're looking at sine in the third and fourth quadrant. So sine inverse, just the acute angle, sine inverse of 1 on root 2 is, I might write it over here, pi on 4. So x minus pi on 4 is going to be our solutions, our related angles in the third and the fourth quadrant, which is going to be pi plus pi on 4, which is 5 pi on 4, and 2 pi minus pi on 4, which is 7 pi on 4. Then we just have to add pi on 4 to both sides, and we get 3 pi on 2 and 2 pi. And those are our two answers. Okay, number 3. 4 sine theta minus 5 cos of theta is equal to a half. Now this example is going to do what the textbook calls approximating using the auxiliary angle method. So I've said before that only a very small number of questions can actually work out in terms of exact form, and this is not one of them. So most of the questions, when we use the auxiliary angle method, is actually approximating, and we're going to get decimals. So if we put it in natural form, it's going to be r sine of x minus alpha. Now the radius is the square root of 4 squared plus 5 squared, which is root 41. Sine of x minus alpha is tan inverse of 5 on 4. Tan inverse of 5 on 4 is approximately 50 degrees 20 minutes, 51 degrees 20 minutes. And that's equal to a half. Divide both sides by root 41, we get sine of x minus 51 degrees 20 minutes is equal to 1 on 2 root 41. Then we're just going to find out, okay, what is sine inverse of 1 on 2 root 41? if I do that, sine inverse of 1 on 2 root 41, we get in degrees 4 degrees 29 minutes. So we're looking at x minus 51 degrees 20 minutes being equal to 4 degrees 29 minutes, and also the corresponding solution, the related angle in the second quadrant, which is going to be 180 minus that answer, which is 175 degrees and 31 minutes. Then we just have to add 51 degrees 20 minutes to both sides. If we do that, let's have a go. 4 degrees 29 minutes plus 51 degrees 20 minutes, we get 55 degrees 49 minutes. And if we add that to 175 degrees 31 minutes plus 51 degrees 20 minutes, we get 226 degrees 51 minutes. Okay, thank you for listening.